Hello, this would be my first video on the lesson of scale drawings, bearings and trigonometry, and let me try and explain this word called as scale drawings in the first place. Now generally what happens is, let's put this as scale drawings. It's very difficult to make when the structure is really very large, when a building is really very large. Before you begin with the work, it becomes really very important that you make a map of that, so that anybody who are the stakeholders within it can understand what's really going to happen at the end of this project. It can be an architectural structure, it can be you're downscaling it and you're making a microchip, okay, that's used. So it has a lot of circuits, and you like to make it at a very miniature scale, and even in that case you like to have some scale drawings made. So what does the scale drawing do? It uses lengths and angles to make a structure which would be coming up, which you are going to see. So a scale drawing could be expressed using ratios, and let's take for example, I have a ratio which says 1:200. 1:200, which means that for every 1 centimeter on the paper, it would represent that 1 centimeter on the paper is going to represent 200 centimeters on the ground. Okay, it could be that way. 1 centimeter on the paper that you're drawing would represent 200 centimeters on the actual. Now when I say 200 centimeters, or if I'm using the unit as centimeters over here, does not necessarily mean that all the while is going to be in centimeters. One thing you must understand is, whenever you use a ratio, both these quantities represent the same unit. This would be so. If it is kilometers on one side, the other one is also kilometers. Likewise for meters, and so on and so forth. Except that this shows the largeness or the magnification that is going to take place. So let's take that I have this small block made. I'm making this small block over here. So this is definitely associated with similarity that you just done and finished. So I have this small block, and I say that I like to have a scale of, okay, as a scale factor of, let's say 1:2. So for every, so it means that, what would that mean over here? So the side over here, which is like 2 centimeters, if I'm making a larger one, is going to become a 4 centimeters. So here we are. So it should be a 4 centimeters, and this should be what it is. And you're making that 4 times larger, 2 times larger rather. So each side is becoming so. So this is becoming 4 centimeters. So the ratio is 1:2. So in the last lesson you've been working with small ratios like 1:2. The only difference here is that you're going to work with larger ratios, 1:200, 1:5000, larger ones, really large ones, because that's the practical truth. Well, so let us look into some examples and try to draw them along, and we'll try to understand how much would that be. So here we are. Let's take your exercise 15.1. Okay, you'll have to have your textbooks besides you. It would be essential. I would not be putting the questions from, I would not be making a image out over here, image from the textbook to be placed over here rather. You'll have to have your textbooks with you. So I'm taking the first question from 15.1 just to make an understanding. It says, on the plan of a house, the living room is 3.4 centimeter long and 2.6 centimeter wide. the scale of the plan is 1 centimeter to 2 meters. Calculate the length, the actual length and the width of the room. So the